How are you, grade 10? I hope you are fine and safe at home. Today we are going to continue our lessons in the fourth quarter. Today's lesson in chapter 9, lesson 9.1, reflections. Okay, let's start together the lesson. We have new vocab here, which is isometry. What's the isometry? It is a transformation that doesn't change the shape or the size of the figure. And the isometry transformations, I have three types of it. The first one here is the reflections. The second one is translations. The third one is the rotations. Okay, so reflections, translations, rotations, all isometric. What the meaning of isometric? That's transformation but doesn't change the shape and or the size. Doesn't change the shape or the size. The isometries are also called congruent transformation or rigid motion. Again, I can call it as congruent transformations. Again, isometry transformations, congruent transformations, rigid motions. Okay, recall this. Recall that a reflection is a transformation that moves a figure. Okay, the pre-image by flipping it across a line. So in the reflection, I must have even imaginary line, that there is a line and I reflect it across it, or flip the figure across this line. Like here, look here, if I have this two, I can imagine that there is a line here in the middle, which is the reflection line, which this figure, the blue one, is flipped across it to give me the red one. Okay, look here, can I make a line of reflection here and flip the figure? You're going to tell me, miss, it didn't flip. Okay, it just transferred, it just translated, it's not reflected. Okay, so the reflected figure is called the image. Reflected figure is called what? The image. A reflection is an isometry. Again, what's isometry? The figure doesn't change in the shape or the size. Okay, so there's no change in the shape or the size. So the image is always congruent to the pre-image. Okay, so here, yes, the image appears to be flipped across the line. Here, it's not flipped across the line. Okay. Reflection is a transformation across a line called the line of reflection. This is the line of reflection. If I have a point A, how to reflect point A across this line? I'm going to make perpendicular line. I'm going to make what? Perpendicular line on the line of the reflection. Then I'm going to measure this distance from A till the line. From A till the line. As example, if I told you this is 2 centimeters, so the image A dash will be also away 2 centimeters from the line of the reflection. Okay, again, this line is perpendicular on the line of the reflection, and the distance between the line of reflection and the point equal the distance between the line of reflection and the image. Okay, or in another word, the line of reflection in the middle of the line between the point and its image. Okay, it's in the middle between the line between the point and the image. So the line of the reflection is the perpendicular bisector. Okay, why? Because it's in the middle. In the middle means bisector. So the line of reflection, perpendicular bisector of each segment joining each point and its image. Okay, very good. How to draw the reflections? If I have a line here and a point, what I'm going to do, I'm going to make a lines which is perpendicular from each vertex. Okay, this line must be perpendicular on the line of reflection, like this. And what? This part must be equal that one. Okay, this distance must be equal that. And here, the distance from the point to the line of reflection equal the distance from the line of reflection to the image. Okay, so easy one. This is for all the vertices. I'm going to transfer the vertices, then I'm going to match them. Okay, so I'm going to transfer each vertices, then connect them together to make the shape. Okay, again, what I'm going to do, we're going to make perpendicular lines to the line of the reflection. Okay, and measure the distance from each vertex to the line of reflection, and locate the image of each vertex on the opposite side of the line of the reflection and the same distance. Okay, then after I make the vertices, I'm going to connect them to make the figure. Connect the image of the vertices. Okay, here I have three types of reflections, three main types of reflections. Okay, the reflection across the x-axis, take care of this. A reflection across x-axis, so x-axis will not change. The value of x will not change. What's going to be changed? The y value. Y value will be negative. So if the point is x and y, this is ordered pair of the point. So the ordered pair of the image is x and negative y. X and negative y. So if I have x and y, and he told you to make reflection across the x-axis, you will keep the x the same. You will keep the x the same. I'm going to opposite the y. Opposite the y. Okay? Very nice. What about across the y-axis? You can think like this here. I said x-axis, so the x will not change. Y-axis, so the y will not change. What's going to change? The x. The x will be opposite. So if this is x, if the point x and y, so its image is negative x and y across the y-axis. I'm keeping the y value the same. I'm keeping the y value the same. Very good. What about any line? Any line that y equal x. Y equal x. The image P is x and y, so the image will be y and x. Let's think. I'm going to give you an example for this. If I have here my order pair 1 and 2, okay, and he tells me to get its image across the line y equal x. So the image will be, where is the y? The y is 2, so y, which is 2, and x, which is 1. So this is my image. Okay, and here, if I have 1 and 2, what's my image? It will be across the y-axis, it will be negative 1 and 2. Very good. Here, if I have 1 and 2, and I told you to give me the image across the x-axis, so the image will be 1 and negative 2. Now you see what's the difference between the three reflections? Very good. Let's solve this example. Drawing reflection in the coordinate plane. This is my coordinate plane. This is my y and x. Okay. And my figure here, M1 and 2. M1 and 2. And put the point M. N1 and 4. N1 and 4 and put the point N. B 3 and 3, 3 and up to 3. Then you are going to join the figure here, so it's rectangle. He wants you to reflect it across the y-axis. This, what is the rule for y-axis? That each x will be opposite. So 1 will be negative 1, 1 will be negative 1, 3 will be negative 3. And what about the y? The y will be the same. So 2 will be 2, 4, 4, 3, 3. Okay? Then plot the points, the image points here and connect it together. Easy one. Okay? Very good. What about this? It tells you to reflection y equals x. Y equals x. So I'm going to use this rule. I'm going to change the values. So if I have 2 and 0, it will be what? What its image? 0 and 2. Here, 2 and 2, there is no change. So it will stay 2 and 2. 5 and 2, 2 and 5. 5 and 1, it's 1 and 5. Then I'm going to put the points and connect them together to draw the figure. Okay? Okay. Thank you, grade 9. This is the lesson for today. It's so easy one. You can study the lesson, and next video we're going to solve the practice in your practice book. Thank you very much, grade 10.